Hello everyone, and welcome back to Band 6100, Foundations of Business for Analytics. In this lesson, we're going to discuss why everyone needs analytics skills. We'll give an overview of the different types of business analytics, techniques, and then discuss a little bit about the approach to problem solving discussed in Keeping Up with the Quants. Analytics is formally defined as the extensive use of data, statistical and quantitative analysis, explanatory and predictive models, and fact-based management to drive decisions and add value. We've already discussed that the main end goal of any analytical inquiry is to make a good business decision. And so in this lesson, we're going to break down some of the techniques that can be used to make these decisions. There are three main types of business analytics. Lately, there have been discussions that there are additional categories of analytics. In this course, we're going to stick with these main three: descriptive, predictive, and prescriptive. Descriptive analytics involves gathering, organizing, tabulating, and depicting data, and then describing the characteristics about what is being studied. So this is really answering the question of what has happened, what is happening, what are the current statistics, descriptive statistics related to the data in the business. A common example of putting descriptive analytics to use is that of business reporting. Anytime aggregate data or individual data are reported about what is happening in the business, this is descriptive analytics. Descriptive analytics is useful for getting an understanding about what is currently going on in the organization, but it does not tell you anything about why results happened or what might happen in the future. Once we've described what has happened and what is currently happening in the organization, we can go beyond describing the characteristics of the data and the relationship among variables and use data from the past to predict the future. A commonly used technique in predictive analytics is that of creating a regression model based on the behavior of past data and the relationships among different factors. We can predict what's going to happen in the future. We can identify the associations among variables and predict the likelihood of a phenomenon. An example of this is that a customer will respond to a specific advertisement by purchasing the product based on an identified relationship. Taking that a step further, we can use prescriptive analytics to answer the question of why something happened and suggest a course of action. So in prescriptive analytics, we can use methods like experimental design and optimization and take predictive analytics even further. This is where decision-making really starts to come in. An example of this would be using an experimental design to try to answer the question of why something happened by conducting an experiment and making a causal inference. Optimization is another example of this, as it attempts to identify the ideal level of a particular variable and its relationship to another. For example, the price of the productive is most likely to lead to high profitability for a product. Techniques like linear programming and integer programming come in handy when conducting optimization. When we're considering data in business analytics, we consider two types of data, so that of qualitative data and quantitative data. You're more likely familiar with quantitative data and the techniques used to analyze it. For example, looking at the number of a specific type of product sold in a specific month. This would be an example of quantitative data. You may not realize this, but categorical data is also quantitative. So things like level of education, whether that's high school or college, while it doesn't appear to be quantitative on the surface necessarily because there's not a number involved, this is still quantitative data, as it can be put into categories and analyzed using quantitative methods. So what is qualitative data? Qualitative data entails things like text. So if you think about looking at Amazon reviews to try and predict what will happen in the future based on previous reviews, you can conduct a sentiment analysis and tease out positive and negative words related to an item. And that which is qualitative can be turned into that which is quantitative for other types of analysis. So here's an overview of different types of analytics, which you'll learn more about in the business analytics course. Some of these have been mentioned before with respect to descriptive, predictive, and prescriptive analytics, as they serve different purposes. You have statistics. These could be descriptive statistics, which fall under the category of descriptive analytics, or inferential statistics, which involve prediction. Forecasting, which is also a predictive method. Data mining, which is a large umbrella that encompasses various techniques used for primarily prediction. That could be classification or clustering. We also have text mining, which can be used for various purposes. Again, this involves analyzing qualitative data. Optimization, which falls under the category of prescriptive analytics, taking a look at what's happened and creating a model that will tell you how much of a particular product you should sell, at what price you should sell it, using different techniques like linear programming and goal-seek analysis. And then we also have experimental design. Very often when you're observing human behavior, it's best to create an experiment to see how the people involved might behave in the future. The phrase big data has been used since around the 1990s, when at that time we were really able to store large amounts of data. And at this point, it's almost kind of evolved into a buzzword, but it's still an important concept in analytics, just to, again, re-emphasize that one of the most important parts of analytics is figuring out what data you're supposed to be looking at and why. And if we consider that the most important resource in the information age is that of attention, we have a limited amount of attention, and we want to make sure that we are targeting the data that best represent our situation, that best describe it, that will be clean and used in the best way to predict what's going to happen and then to make decisions. So again, the goal of any analytics is good decision making. This can occur at lots of different levels of the business: strategic decision making, operational decision making, managerial decision making. And different types of analysis can be used to make these decisions at different levels of an organization. If you think about what products should we sell, how much of each product should we sell, how much inventory should we keep on hand, what customer base should we be targeting? Should we be targeting a new customer base? Where should we be selling? How should we be selling? And the list goes on. So analytics can really be used in any part of the organization to make any type of decision. But again, that decision is going to have to be made jointly between the analytical tool and the analyst themselves. In the text Keeping Up with the Quants, they discuss 3 stages and 6 steps of quantitative analysis. We pulled this text for this course because it is not only important to understand how to conduct the analysis, but also how to think like a scientist, in the sense that sometimes it's not clear what questions you should be asking in the first place when it comes to improving an organization. Sometimes the data will have to speak to you in a way that you're not sure of yet. It's possible you don't even know what the problem is yet, and you need to do some exploratory data analysis in order to figure out what kinds of problems there are. So the 3 stages of this kind of analysis involve first framing the problem. I would include discovering the problem in that as well. Then the actual solving of the problem. This is the part that I think most people consider to be analytics, where you're actually using the tools and techniques to find a solution to the problem that you've framed. And then finally, communicating and acting on the results that you have found. And this last piece involves things like data visualization and giving a presentation. Within these 3 stages, we have 6 steps of quantitative analysis that Kim and Davenport have outlined. And this isn't meant to be a rigid set of steps to follow. It is more just a set of guidelines and description of the whole problem-solving framing process from start to finish. So I don't want you to necessarily think that, okay, well, I have to first identify the problem, then review previous findings, and then model, and then keep going. Maybe after you've done the modeling, you've identified a new problem, and that's kind of reframed what you need to do. So the steps are kind of iterative in a sense. In fact, sometimes I would say you could start with data collection itself before you even recognize that there is a problem. Or maybe you've collected data, you've done some analysis, and then you identify a problem. But for the sake of starting somewhere, let's go ahead and take a look at each of the steps that they outline in Keeping Up with the Quants. So the first is that of problem recognition. We first have to identify a problem, that there is some need within the organization that has to be addressed. This could be a gap in sales in a particular area, could be a dip in profits during a particular month in the year, but at some point there is a problem and we have identified it. Once the problem's been identified, then we can review previous findings. Is there anything related to our problem that could be useful when thinking about modeling and discovering a solution? Are there associations between a specific season and the type of product that we're selling, for example? Once we've taken a look at some historical information and previous findings, then we can think about modeling. So once we move to the modeling stage, then we're actually solving the problem. Personally, I would say that the modeling step is the most difficult. If you haven't modeled the problem correctly, then it doesn't accurately reflect what's actually going on, and when you find a solution, you've actually found a solution to a problem that you're not actually interested in. So the modeling step is very, very important. The type of modeling will depend upon the type of analysis that you're doing, as well as the type of problem that you're investigating. This is a very open-ended step in which you may have to go through many iterations figuring out exactly how to model the problem. Once the problem is properly modeled, then you can go seek out data that will help you actually solve it. This step's also extremely important because if you get bad data, then your solution will not accurately reflect the problem that you're trying to solve either. You want to make sure that you've collected enough data as well to make sure that you have accurately reflected the situation. So the key here is to make sure you get the right data, that your data is clean and ready to go into the model, and that you have enough data Once you've got your problem modeled and you have the right data, enough data, clean data, then you're ready to actually conduct the analysis. I would say that step 5 is probably the easiest of the 6 steps. This is actually where you plug everything in and you simply conduct the analysis. This is the most quantitative piece of the whole process. And typically, I think what people think of when they think of data analytics as a concept. Once the analysis has been conducted, we're not quite finished though, because somebody has to make a decision based on what the findings are in order to solve the problem. And in order to make that decision, what we need is to communicate the results to the right person at the right time. So then we move into the presentation of results and the actual resulting action. And this is a whole art and science in itself, that of data visualization. So again, we can kind of categorize and classify the different steps of quantitative analysis. I wouldn't say that they all have to take place in this particular order, and much of the time you'll probably end up bouncing back into recognizing the problem or the modeling stage, depending upon what you find and what data you've collected. It's a very circular process, but at the end of the day, it's all about making the decision based on the results that get presented. The hope at the end of this module is that you'll begin not only considering the different analytical possibilities, but that you'll also begin thinking like a scientist. Look at the world around you. It doesn't even have to be an organization. It could be just any topic you're interested in, whether that's sports or music or food. Stop and think, what kind of phenomena am I observing? Maybe I've noticed that, okay, when these players are involved in this particular game, things happen to go well. You make the observation, and then you kind of start to think about why. Is there a problem that you can identify from the observation that you've made? Take a few steps back from your typical analytical brain and just kind of observe. Begin to be curious about the world around you, if you're not already. I know it's a very difficult thing to do in the fast-paced world in which we live in, and given that you have so many things to do. But I promise that secrets abound even in the smallest of places and the most mundane of tasks that you complete every day. So go out there and begin to think like a scientist. If you have any questions about this module, please let me know.